Welcome to this explainer, everyone. Today, we're making a massive shift in how you think about your work. We're going to transition your mindset from just writing code to pass an assignment to actually architecting solutions for real human problems. You're learning to be software engineers, and that means mastering the foundations of client-centric design before you type a single line of syntax.
Right off the bat, I want you to ask yourself a super important question. Who are you actually writing this code for? We've got to bust that stereotype of the lone programmer fueled entirely by caffeine just staring at a dark screen in a basement. The code you write doesn't exist in a vacuum, you know? It interacts with the real world.
So, here's our roadmap for today. First, we'll meet your future client. Next, we'll dig into the root business problem. Third, we'll cover manual to digital transformation. Fourth, defining the software project. And finally, getting from the problem to the project.
All right, Section 1. Meet your future client.
You know, this journey actually starts way before you ever open your IDE. The client is the absolute anchor of your entire project. They're the individual, the business, or the organization experiencing serious friction in their daily operations. Without them, there's no project. There's literally no software to build. Everything you do as an engineer originates directly from their need.
And these clients? They are incredibly diverse. You're not just building stuff for other techies. You might be designing for a solo startup founder hustling out of a garage, a strict government official, a hospital administrator managing thousands of patients, or even a massive multinational company moving millions of dollars. Your ability to adapt and really understand these different worlds, that is your superpower as an engineer.
To really get this, let's build some empathy. Just picture a hospital for a second. Imagine the absolute chaos and, frankly, the danger of a medical center trying to manage patient records, allergies, and bed assignments without a centralized, reliable database. Or think about a supermarket trying to manually count every single can of soup on the shelf every night. That's basically like counting grains of sand on a beach. These common software needs aren't just technical requirements, they are absolute lifelines for these organizations.
Moving right along to Section 2, the root business problem. So we know who they are, but why are they coming to you in the first place? What's keeping them up at night? Well, it usually goes like this. First, they experience a daily inefficiency. Things are just too slow. Second, they hit a total operational breaking point where the old way simply cannot scale anymore. Maybe they're losing customers or making critical errors. It's only then, in Step 3, that they actively seek a technological solution. You're stepping in at Step 3, but to do your job right, you must completely understand the pain of Steps 1 and 2.
Let's be real. Your clients aren't buying software just for fun. They honestly don't care about the elegance of your sorting algorithm just for the sake of it. They are buying solutions to massive operational headaches. They need software because their current reality is causing them intense stress, it's losing them hard-earned money, or it's wasting incredibly valuable time.
And here's the thing. Before they even pick up the phone to call you, they've been dealing with some massive internal hurdles. They might even struggle to identify their exact problem. Plus, they have strict budget constraints, and they often feel intense technical intimidation. Remember, they aren't engineers like you, so your technical jargon might sound like an alien language to them. Add in a deep human fear of change, and it's a lot. You have to empathetically understand these challenges to communicate effectively and build trust.
Which brings us to Section 3, Manual to Digital Transformation.
Think about the stark contrast between the old way and the new way. On one hand, you have the absolute frustration of manual systems. They're slow, error-prone, drowning in paper, and physically constrained by human limits. But on the other side, that's the computerized system you're going to build. It's lightning fast, beautifully automated, endlessly scalable, and centrally managed. Your job is literally building the bridge from that manual chaos to a streamlined future.
This entire shift from paper to pixels is what the industry calls digital transformation. Yeah, it's a huge buzzword, but this is the real ground-level definition. It's the integration of digital technology into all areas of a business, fundamentally changing how it operates. And you, the student software engineer, you are the actual architect of that shift. You're the one making this transformation possible.
Okay, Section 4, defining the software project. Now that we really get the client's pain, we finally step into our technical domain. What exactly is a software project? Well, it's a structured, planned endeavor to design, build, and deliver a digital solution to the client's problem. It is definitely not just opening an editor and haphazardly typing code until something magically works. It's a highly organized, deliberate mission to solve the very specific issues we just spent the last few minutes outlining. And every single professional project you tackle is going to share a few core characteristics. It has a distinct start and a distinct end date. It operates within a specific, unforgiving budget. It has a strictly defined scope of what will and won't be built. It requires resources, like your time and computing power. And above all, it aims to solve a specific problem. These constraints are what frame your technical work within strict, real-world business boundaries.
Let's bring it all together in Section 5, from problem to project.
This right here is the true aha moment for any engineering student. It's where we connect that initial frustration directly to your deliverable. A raw business problem sounds like a messy complaint, right? Something like, "We are losing supermarket inventory." It's vague and it's stressful. But a structured software project translates that into an actionable technical goal, building an automated barcode tracking database. Translating that messy complaint into a concrete architectural goal, that is the true art of software engineering.
You can literally trace this life cycle step by step. It shows how a messy, chaotic problem in, say, a supermarket or a bank naturally transforms into a clean architectural vision that you will eventually code. It starts as a manual problem, gets recognized by the client, shapes into a strategic plan, and finally lands right on your desk as a formal software project.
All right, let's wrap things up with a quick chapter summary and review.
To recap, before you start writing any actual code, remember that your job as an engineer begins way before the keyboard is involved. It is rooted deeply in empathy for the client's struggles. The journey always starts with the client. It pivots on that shift from manual to digital to solve their real-world problems, and it ultimately culminates in the structured software project that you are going to execute.
I want you to test your own understanding right now. Try answering these 5 review questions derived from our session today. Can you define what a client actually is? Can you name 3 types? Can you contrast manual versus computerized systems? How about accurately defining a software project? And most importantly, can you differentiate a raw business problem from a formal software project? If you can answer these confidently, you're ready to begin.
And finally, I'm going to leave you with a thought to carry into your very first real-world assignment. If you sit down to code, but you don't truly understand the client's business problem, what are you actually building? Are you building a solution or are you just typing? Think about that and always keep the client at the center of your architecture. Thanks for joining me for this explainer, and I'll see you next time.
Imagine this. You've just spent months of your life and literally millions of dollars on a critical tech project. But halfway through, you get that sinking feeling. You realize the partner you chose fundamentally doesn't understand your business. Or worse, they just don't have the skills to actually deliver. It is a high-stakes nightmare. And honestly, it happens all the time in the corporate world. But hey, it doesn't have to happen to you. So how do you choose the right tech partner without wasting all that time and capital? Well, consider this explainer your ultimate survival guide to navigating the tech wilderness.
Welcome to the explainer. Today, we're going to completely demystify the complex process of evaluating and contracting a software or IT partner. Making the right choice in a vendor is absolutely one of the most critical decisions your business can make today. So, we are going to break down the exact strategies, the key metrics, and the legal safeguards you need to make sure your next technology partnership is a resounding success.
Okay, let's dive into this. Here is our roadmap for today. We'll start by navigating the tech landscape, then move into finding your ideal partner and evaluating those key partner metrics. After that, we'll walk through the specific vendor selection steps, break down contracts and payment models, and wrap it all up with a final review. First up, navigating the tech landscape.
Look, the absolute first step to finding a reliable partner is knowing exactly what kind of team you actually need. And there is a massive industry misconception right here. On the left side, software companies. These are your builders. They code applications from the ground up, they create your digital products, and they design your software. But on the right side, IT companies. These are your managers. They handle the infrastructure, they keep your networks running securely, and they manage your hardware. Mixing these two up, that will derail your project before it even starts.
But, even within software companies, you've got these really distinct specialties. You have agile startups, established product companies, broad service companies, and strategic consulting firms. Plus, today we're seeing these hyper-specialized AI and cloud companies popping up everywhere. And the type of company you choose, and crucially, where they are geographically located, well, that dictates a tremendous amount. Geography heavily influences time zones for your daily meetings, the cultural communication nuances, and ultimately the hourly rate you're going to be paying.
Moving on to Section 2, Finding your ideal partner.
Now, finding that perfect partner isn't just about throwing a dart at a Google search. While you'll absolutely use standard tools like your professional networks on LinkedIn or industry referrals, the absolute secret sauce here is ruthless validation. Because let's face it, anyone can buy a slick website or a great marketing pitch. You need to dig deep into independent reviews, study their portfolios, and really scrutinize those past case studies to find tangible, undeniable proof of their competence.
All right, Section 3. Let's highlight those key partner evaluation metrics.
Once you have your shortlist, well, the stakes get a whole lot higher. You really need to use an ultimate scorecard. Notice how we aren't just looking at the price tag here? Clients absolutely must weigh these interconnected metrics: cost, quality, experience, technology, communication, support, and security. Because think about it, if you just chase the cheapest bid without checking their security protocols, you are literally setting yourself up for a devastating data breach. Or if you ignore communication standards just because they have high technical skills, your project will stall out. All of these have to be evaluated together.
To put this into perspective, let's look at a typical decision weight distribution. A really smart client might put 40% of their decision weight on experience, 30% on cost, and another 30% on communication and support combined. The crucial takeaway here is that smooth communication and ironclad security are often just as vital to a project's survival as that final price tag. Because if your partner can't communicate delays effectively, your initial cost savings, they're going to evaporate instantly. Section 4. Let's illustrate the actual vendor selection steps. This is the chronological flow of really putting those vendors to the test. Step 1 is requirement gathering meetings. And yes, I know, this means surviving endless alignment meetings. But getting your requirements locked in right here is absolutely vital. Skip this and you're going to build the completely wrong product. Step 2 moves into proposals, quotations, and demonstrations. This is where the vendor finally proves they actually get your vision. And finally, Step 3, the negotiation process. This is that pivotal moment where all your rigorous metric evaluation pays off right before you lock things in.
Transitioning over to Section 5, contracts and payment models.
Welcome to the paperwork. Let's do a really quick rapid-fire legal dictionary, starting with the NDA, or non-disclosure agreement. Listen, before you even show a vendor the inner workings of your business, this needs to be signed. It protects your confidential info and your intellectual property. It is your absolute first line of defense for protecting your brilliant ideas.
Now, while the NDA protects your ideas, the SLA, the service level agreement, that guarantees the quality of the service provided. This document defines exactly what uptime is expected, how fast the vendor has to respond to a critical bug, and, crucially, what the financial penalties are if the service drops below those agreed upon standards.
And then we have the Statement of Work, or the SOW. Guys, this is the absolute bedrock document of your entire project. It details the project-specific activities, the exact deliverables, and the timelines. The golden rule here: if it is not in the SOW, you shouldn't expect it to be built. This document keeps everybody completely accountable.
So, how does this all build into payment models? Well, here's a side-by-side of the two most common structures. On the left, the fixed price model. You know exactly what you're going to pay up front, but there is very little flexibility if you want to change features later on. On the right, the time and material model. Here, you pay for the actual hours worked. The general rule of thumb: use fixed price for a rigidly defined scope and use time and material when you need the flexibility to evolve, just keeping in mind that you carry more of the financial risk if things take longer than expected.
There are a couple of other models to consider too. You might hire a dedicated team for long-term work, use a subscription model for ongoing software services, or use milestone payments. I highly recommend looking at milestone payments tied to project approval. Why? Because this ensures you only release funds when real, verifiable progress is demonstrated and officially approved by your team. It's a great safety net. Finally, Section 6, our final review and summary. We've covered a tremendous amount of ground today. But if you take away just one single thing from this explainer, let it be this: successfully outsourcing your technology is not based on luck, and it's certainly not about trusting a really good sales pitch. It is entirely about following a logical, step-by-step evaluation process. It requires structured searching, rigorously evaluating those key metrics we highlighted, and locking it all down with bulletproof contracting.
So I'm going to leave you with this one final question to test your own readiness. Look at your own projects. Based on the ultimate scorecard we built today, are you truly ready to sign that contract? Or do you maybe need to step back and reevaluate your partner's security and communication metrics? Seriously, Don't rush the process. Use this framework, protect your business, and go find a partner that will actually help you build the future. Thanks so much for joining me on this explainer, and happy hunting.
Welcome to this explainer. If you've ever wondered how a simple idea transforms into a massive functioning application, you are absolutely in the right place. Today, we're going to demystify exactly what happens inside a software company the moment a project gets the green light. We're laying out a developer's essential team roadmap, exploring the specific phases, the people, and the processes that turn abstract concepts into actual working code. Here's our roadmap for today. We're going to hit the project kickoff, meet the development team, dive into analysis and project planning, look at software architecture, cover development and deployment, and then tie it all together with a quick summary and review. Let's get into it. All right, starting off with Phase 1, the project kickoff. This is all about setting the target. So picture this. The executives have shaken hands, the budget is officially allocated, and the project gets the green light. What happens next? Well, it's time to completely shatter the illusion that coding is just some solo endeavor happening in a dark basement somewhere. It's actually a massive, highly coordinated group effort, and it all kicks off right here. This meeting is where the overarching vision is shared, and the massive wheels of this corporate machine finally start to turn. To really understand how those wheels turn, we have to talk about the SDLC, the Software Development Lifecycle. Think of this not just as a flowchart, but as the actual operating system for our entire mission. It represents the strict physical boundaries of the developer's essential team roadmap we're exploring today. It's the master playbook that guides the team through planning, designing, developing, testing, and deploying. Literally every single person on the team operates within this lifecycle to keep chaos at bay. Moving right along to Phase 2, meet your development team. It's time to assemble the crew. Okay, so we've got our playbook. Now let's look at the actual people, the 14 essential roles that make up this team hierarchy. Instead of just giving you a dry list, look at how these roles group into functional squads. First up, you have the planners setting the vision. That's your business analyst and project manager. Next are the builders doing the actual design and coding. And finally, we have quality and ops, ensuring everything is secure, functional, and supported. Every single role here is a totally vital gear in the machine. Zooming in on our builders, there's this absolutely crucial partnership between the front-end and back-end developers. It's a real balancing act. They have to constantly navigate the strategic friction of merging what the user actually sees and experiences with the hidden machinery that makes the app work. And occasionally, those skill sets merge into one highly versatile role, the full-stack developer, who bridges that gap entirely. And over on the protection side of the team, the dynamic is just as fascinating. People mix these up all the time, but the QA engineer and the software tester have distinct complementary jobs. The QA engineer designs the overarching testing processes. They're essentially building the ecosystem of quality. Meanwhile, the software tester is right there in the trenches, executing those tests and literally trying to break the software to find flaws before the users ever see them. Which brings us to Phase 3, analysis and project planning, laying that solid foundation. Look, before a single line of code is even written, our planners execute requirement analysis, a feasibility study, and project planning. Why? Because this is where the planners protect the builders from scope creep and totally impossible expectations. It's pure risk mitigation. By mapping out what is actually technically and financially possible, they build a firewall against wasted resources and set a timeline that the team can actually hit. Next up is Phase 4, designing the software architecture. Essentially, creating the blueprints. Once the planners have laid that foundation, the software architect and UI/UX designer step up to translate those requirements into actionable blueprints. We're talking critical design artifacts here: UML, wireframes, database designs, and the overall architecture. And think of these not just as diagrams, but as a strict contract between what the planners promised and what the builders will actually execute. These schematics are what ensure the final application is structurally sound. All right, on to Phase 5, development and deployment, building and delivering the actual product. This right here is the engine room. It's the execution phase where the actual development happens. Developers and DevOps engineers utilize a modern pipeline, heavily relying on Git for version control and CI/CD pipelines to seamlessly deploy code. This setup provides the velocity to deploy frequently, while mandatory peer code reviews act as the ultimate safety net, catching bad code before it causes problems. But hey, this high-speed engine doesn't just run on code. It absolutely requires constant internal communication across all 14 of those roles we talked about. And a huge shout out to the technical writer here. They're often overlooked, but they are the glue that prevents institutional knowledge from being lost. They provide the ongoing documentation so that current and future team members know exactly how this massive, evolving system works. And finally, we arrive at Phase 6, Summary and Review. Time for the debrief. Let's wrap up this developer's essential team roadmap and look at how this machine operates as one cohesive unit. It really is a beautiful flow of accountability. Kickoff gets approved. The planners do their deep analysis to protect the scope. The architects translate that into a strict design contract. The developers build it safely via Git and CI/CD. The ops team rigorously tests it. And finally, the support team maintains it for the end user. To close out this explainer, I'll leave you with a few review questions from the source text, but the most important and maybe most provocative question you should be asking yourself right now is this. Where does your own role, or the role you're aiming for, fit into this incredible software development roadmap? Because understanding how you fit into this big picture is absolutely key to thriving in the tech industry. Keep exploring, and I'll catch you in the next one. All right, welcome to today's explainer. We're jumping straight into the software lifecycle. We interact with apps, platforms, and digital tools literally all day long, right? You tap a button on a piece of glass and boom, a car arrives at your exact location minutes later. It feels like absolute magic. But for a lot of folks, the actual creation process behind that magic is just completely hidden behind a thick curtain of code and jargon. Well, today, we're ripping that curtain back together. So here's the big question. How does an idea actually become an app? You might have this brilliant, industry-disrupting concept, and you might even have the funding to back it up, but crossing that gap from a cool, abstract idea to a fully functioning product, for a lot of leaders, it's just a black box, and it can be super intimidating to navigate a space where you don't even speak the native language. So today, we're going to illuminate that black box. We are mapping out the entire software development lifecycle, step by step, so you can see exactly how the gears turn, from that very first handshake to the final code deployment. Here's our game plan for today. We're covering 1. Defining the tech landscape. 2. Choosing the right partner. 3. Contracts and payment models. 4. Meeting the development team. And 5. Mapping the development stages. Section 1. Defining the tech landscape. Who builds what? Okay, let's clear up a massive misconception right out of the gate. Because before you can hire someone to build your app, you really have to know who to look for. You'll hear software company and IT company tossed around in conversation like they're the same thing. They absolutely are not. Software companies are your product creators. They write the raw code to bring brand new digital products to life. They're the inventors. IT companies, on the other hand, are your infrastructure and support teams. They set up corporate networks, fix the Wi-Fi, keep servers running smoothly. So if your company email goes down, you call IT. But if you want to build a brand new mobile app from scratch, you definitely need a software company. And even within the software realm, there is a huge diversity of expertise. You've got agile startups, dedicated product companies, service agencies, high-level consulting firms, and super specialized outfits like AI or cloud companies. The one you choose depends entirely on what you're actually building. Just need a simple e-commerce storefront? An agency might be best. Building a wildly complex machine learning algorithm? You're going to need an AI specialist. Geography plays a big role here too. Clients have to constantly weigh the ease of hiring a local team in the same time zone versus partnering with an overseas agency to really optimize those development costs. Section 2, choosing the right partner. The search and evaluation. So how do you actually hunt down this ideal tech partner? Well, it starts like any major search. You leverage Google, lean on referrals, scour LinkedIn, but what clients are truly looking for are strong trust signals. They're digging into previous portfolios, reading unvarnished client reviews, and scrutinizing detailed case studies. Because honestly, anyone can build a shiny website, right? A history of actual successful software deployments is what really matters. Think about it just like hiring a contractor for a house. You'd never hand over your life savings without walking through a house they already built. Once you've got a short list, the rigorous filtering really kicks in. You're evaluating on cost and quality, of course, but it goes way deeper than the price tag. Has this team built a healthcare app before, or just financial tools? What specific technology stacks do they specialize in? And crucially, how do they communicate? Security protocols and long-term post-launch support are massive deciding factors too. Only the vendors who score highly across these specific metrics are actually going to make it to the proposal phase for product demos and requirement gathering. Section 3. Contracts and payment models. Sealing the deal. All right, the formal handshake phase. This is where those optimistic meetings turn into legally binding agreements. And there are 3 documents you absolutely need to know. First up, the NDA, or Non-Disclosure Agreement. You sign this early on to keep your brilliant idea top secret. Next is the SLA, the Service Level Agreement. This clearly defines expected performance standards and uptime guarantees. And finally, the Statement of Work, the SOW. This is the holy grail of any project. It outlines the exact scope, every single deliverable, and the timeline. It's your ultimate shield against scope creep. Seriously, if a feature isn't explicitly detailed in the SOW, it's simply not getting built. So how does the money actually flow? Let's break down the standard models. Fixed price is fantastic for smaller projects with a very clear, unchanging scope. You know the exact cost upfront. But if you're building something complex where requirements might shift, like a novel AI tool, time and material gives you that much-needed flexibility. You pay for the actual hours worked as the project evolves. You could also just hire a dedicated team full-time or use a subscription model for ongoing services. But no matter which model you choose, financial risk is almost always managed through milestone payments, meaning your funds only get released when specific, predetermined stages are formally approved. Section 4. Meet the development team. Inside the machine. Okay, we're crossing the conceptual bridge into Act 2 here. The contract is signed, the kickoff meeting is done, and we are stepping directly inside the software company to meet a massive roster of talent. Let's go back to our house building analogy to make sense of this. The software architect and project manager, they're basically your lead foreman, drawing up master blueprints and keeping everyone on schedule. UI/UX designers are your interior decorators, making sure everything looks stunning and flows perfectly for the user. Developers, whether they're front-end, back-end, or full-stack, are your core crew, pouring concrete and running the electrical wiring. And the QA testers, security analysts, and DevOps engineers, they act as the rigorous building inspectors, meticulously checking the work so the house doesn't collapse or get broken into. Section 5, Mapping the Development Stages, the Lifecycle Flowchart. Now, let's map out the exact progression of this lifecycle. Visualizing development stages with flowcharts is absolutely critical because it takes a chaotic, raw concept and shows you how it systematically becomes a real product. This timeline right here shows the macro flow. We start with the kickoff, then we flow straight into requirement analysis and feasibility. This is where the team basically asks, can we actually build this with current tech? Once verified, that flows into project planning, then design, then heavy development, and finally release. Visualizing these stages clearly shows you can't skip steps, you just can't design without planning, and you definitely can't code without a design. Let's zoom into that design node for a second to see what happens before a single line of real code is ever written. Precise digital blueprints are made in a very specific order. First, the team maps out the system logic using UML diagrams to show how different pieces of software will talk to each other. Second, they build wireframes, those simple black and white skeletal outlines showing where the buttons and menus will actually sit. Third, database architecture. They figure out exactly where and how user data is going to be safely stored. Following this highly structured flowchart means there is zero guesswork when the developers finally step onto the site. Moving over to the development node, code isn't just typed recklessly in a dark room. It follows its own strict process flow to maintain quality. It starts with version control, usually Git, which carefully tracks every single keystroke so developers can roll back mistakes instantly. Then comes mandatory code review, where peers hunt for hidden bugs in each other's work. Finally, we hit CI/CD, continuous integration and continuous deployment. This is an awesome, highly automated pipeline flowchart that tests new code and seamlessly pushes it out live. Visualizing this really reveals a disciplined factory assembly line. Now, across all of these incredibly complex stages, from the initial logic flowchart to that final code deployment, 2 things are the ultimate glue holding it all together: constant team communication and meticulous technical documentation. You've got so many specialists working on different rooms of the same digital house. If a back-end developer tweaks how a database works, the front-end developer needs to know that immediately. If they aren't talking daily and rigorously documenting what they built, the entire structure is going to quickly fall out of alignment and just break. So, to wrap this all up, the software lifecycle transforms a raw idea into a finished product through rigorous planning, structured contracts, and phased development stages. That perfectly captures everything we've explored today. When you treat the creation process as a structured lifecycle, starting on the outside with careful vetting and contracts, and moving inside by visualizing development stages with clear flowcharts, you completely destroy that black box mystery. You replace all that fear and uncertainty with a reliable engine built for success. Which brings us to one final big question. Is your next big idea ready for the life cycle? Now that you know the exact steps, from choosing the perfect partner to navigating these intricate flows of development and deployment, you are fully equipped to bring your most ambitious digital visions to life. Thanks for hanging out with me for this explainer, and keep exploring. Welcome to This Explainer. Today, we're diving straight into the fascinating hero's journey of code. We're tracking its exact path, taking it from raw initial development all the way to a polished production-ready product. Because, let's face it, it is an incredibly long, complex road from a developer's keyboard to your smartphone screen. So let's chart the map. Here is how we're breaking it down today. First, the testing gauntlet. Second, the bug lifecycle. Third, deployment steps and examples. Fourth, the client handoff. And finally, a chapter review. Section 1. The testing gauntlet. So when you map out the macro journey, develop, test, deploy, and sign off, you quickly realize you can't just write a bunch of code and, hope for the best. Testing is that absolute non-negotiable barrier that stops the whole system from completely crashing on launch day. It's essentially the process of actively trying to break your own creation before anyone else gets the chance. The code faces escalating layers of defense. It starts super small with unit testing, basically checking if a single digital gear works. Then, integration testing steps in to check if those gears actually spin together without jamming up. Next, system testing evaluates the entire machine, and acceptance testing makes sure it, actually does what the client asked for. Finally, we completely batter it. Performance testing simulates heavy traffic. Think of a massive Black Friday sale. And security testing locks all the doors against hackers. Section 2, the bug lifecycle. Testing inevitably uncovers total chaos, right? And managing that chaos is absolutely crucial. A bug status starts out as found, which is officially logged by the testers. Then it immediately moves to fixing, where the developers swoop in to save the day. But my absolute favorite part of the workflow is verifying. The bug bounces back to the testers for regression testing. They aren't just checking the fix, they are aggressively making sure the developer didn't accidentally break some completely different previously working feature in the process. It happens way more often than you'd think. Section 3, deployment steps and examples. Now, deployment is absolutely never one size fits all. Take a cloud deployment, for instance. A massive streaming service completely thrives here because it needs highly elastic resources to handle, say, millions of users logging on at the exact same time for a big Friday night movie release. On the flip side, an on-premises deployment is vital for something like a highly secure internal hospital database. They need the literal, physical security of servers located right inside their own building. And naturally, a lot of organizations opt for a hybrid of both. Deployment is not just flipping a magic switch, it is a meticulous, step-by-step workflow. Let's think back to that hospital example for a second. First, you have data migration, which means carefully moving decades of highly sensitive legacy patient records into the new system. Second is user training, literally teaching the nursing staff how to use it. Third, client demonstrations, proving it actually works in a live environments. And only then do we hit that final go-live process, where the new system officially takes the reins. Section 4, the client handoff. Let's unpack a really critical industry acronym, UAT, or User Acceptance Testing. This is the final phase where the end users actually take the wheel in a real-world scenario. We aren't hunting for tiny, obscure code bugs anymore. No, this is the exact moment the client actually realizes the value of their investment by asking one very simple question. Does this actually solve my business problem? Alongside UAT, the development team has to execute a completely smooth transition. That means hitting two major handoff essentials. First, establishing production support, so someone is actually there to pick up the phone when the client inevitably has a question on day 2. And second, the documentation handover. This is literally handing over the keys and the owner's manual so the client's own IT team knows how to maintain the vehicle going forward. The ultimate goal of this entire massive life cycle boils down to one thing: 100% completion. Once UAT is passed, support is established, and the docs are handed over, you achieve formal client sign-off. That single signature represents the end of the project and, most importantly for the business side of things, the release of the final payment. Section 5, Chapter Review. So, we have covered a tremendous amount of ground today. It's abundantly clear that code simply cannot launch without going through a structured, multi-stage journey, navigating a rigorous, layered testing gauntlet, managing a strict bug lifecycle, tailoring structured deployment environments, and finally earning that formal client acceptance. Let's quickly recap what we've discovered. Can you recall those 6 specific phases of the testing gauntlet? Remember, they scale all the way up from the micro to the macro. Unit, integration, system, acceptance, performance, and finally, security testing. And what about the bug lifecycle? What is the crucial step testers perform immediately after developers implement a fix? Right, it's regression testing, making absolutely certain the new code didn't somehow break a completely different, previously working part of the application. We also looked heavily at deployment environments. How does a cloud deployment practically differ from an on-premises deployment? Well, a cloud deployment relies on external servers for massive elastic scalability, while an on-premises deployment relies on physical internal servers to maintain absolute lockdown security over highly sensitive data. Now, what is the sequence of the 4-step deployment workflow leading right up to the go-live process? To safely transition users onto a new system, we follow a strict sequence: data migration, user training, client demonstrations, and then finally, the go-live process. And for our last review question, what final milestone must be achieved before the final payment is released? That would be formal client sign-off. This triggers the final payment, but only after successful user acceptance testing and that crucial documentation handover. It is genuinely wild to think about the invisible gauntlet of testing, fixing, and deploying that is relentlessly happening behind the scenes. The next time your favorite app seamlessly updates overnight, ask yourself, how many bugs were squashed and how many precise deployment steps were executed just so you could tap that screen? Thanks for joining this explainer, and never stop looking behind the digital curtain.
Welcome to today's Explainer. I am absolutely thrilled you're here, because today we are going to completely destroy a massive myth in the tech world. You know, so many people think that once a software application is launched, once you actually hit that deploy button, well, the story's over. You pop the champagne, high-five the team, and move on to the next thing. But honestly, nothing could be further from the truth. Launch day isn't the finish line, it's literally just the end of the prologue. Today we're looking at what happens next. We're going to trace the post-deployment hero's journey of software. And since I know a lot of you are prepping for finals right now, this explainer is designed as a masterclass exam review. We're going to make sure your notes are totally airtight so you can ace those upcoming tests. Okay, let's dive into this. Here is our syllabus for today's masterclass. We'll be covering life after launch, the 4 pillars of maintenance, some real-world case studies, the art of closure, careers and practices, and we'll wrap the whole thing up with an exam review module.
Section 1. Life after launch. The journey continues. So I want you to think of your newly deployed software as our hero. In development, it was protected, nurtured, and tested in these perfectly safe environments. But once our software hero steps out into the wild, it enters a massive, unpredictable new terrain. And this brilliantly illustrates the complete end-to-end timeline. Most textbooks focus heavily on everything before launch, but look at all the ground we have to cover after day 1 launch. Right after deployment, we enter the warranty period. This is the initial support phase where the dev team is on super high alert, fixing any immediate day 1 bugs that somehow slip through testing. It's a high-intensity phase. But as things stabilize, we transition into step 3, the annual maintenance contract, or AMC. This is the ongoing support phase, and it can last for years. Finally, when the software reaches the end of its useful life, we don't just abandon it. We enter step 4, project closure. Understanding this flow is absolutely crucial because it frames everything else we're about to talk about.
Moving right along to Section 2, the 4 pillars of maintenance.
During that long AMC phase we just talked about, the industry relies on 4 distinct types of maintenance to keep systems running. First up is corrective maintenance. Now, if you're studying for your exam, pay close attention to this next distinction. Corrective maintenance is exactly what it sounds like, correcting things that are actively broken. It is the immediate, reactive bug-fixing phase. So when a user clicks a checkout button and the app crashes, customer support generates a service ticket, and the development team swoops in to apply a hotfix, it's basically putting out fires. It is vital for sure, but if it's the only maintenance you're doing, your project is in serious trouble.
And that leads us to the second pillar, preventative maintenance. If corrective maintenance is reactive, preventative maintenance is highly proactive. This is all about looking ahead and asking, how can we stop the software from breaking in the first place? It involves routinely applying security patches to defend against new cyber threats, or doing under-the-hood performance optimizations so the server doesn't just crash when user traffic spikes. You are essentially fortifying the software hero's armor before the battle even begins.
Now, what's really interesting about this slide is the crucial contrast between our final two pillars. Students mix these up on tests all the time. Adaptive maintenance is entirely driven by the environment. Say Apple releases a new iOS update, or you migrate your app to a new cloud server. Your software has to adapt to survive. It's not necessarily gaining new features, it's just staying compatible. On the other hand, perfective maintenance is driven by the users. This is the fun stuff. It involves adding feature enhancements, executing major version upgrades, and just generally making the software better, faster, and more user-friendly. So remember, adaptive response to the environment, perfective response to human desire. Definitely write that down.
So who's actually doing all this work? Well, notice how the responsibilities shift over time here. During the warranty phase, developers are heavily involved in handling service tickets right alongside customer support, quickly resolving those corrective maintenance issues. But as we transition into the long-term AMC phase, customer support really takes the front line for tickets, while developers shift their main focus over to perfective version upgrades. Finally, during closure, the client becomes the central figure, reviewing the deliverables and providing the final sign-off. It's this carefully choreographed dance between all three roles over the entire life cycle.
Section 3. Real-world case studies. Let's ground these theories in reality.
Think about how wildly different these environments are. For a hospital management system, corrective maintenance is literally life or death. Downtime just isn't an option. For a college ERP system, adaptive maintenance is huge, especially when you're suddenly shifting thousands of students to remote learning environments. But look at a banking application. Their absolute top priority is preventative maintenance. They are constantly deploying security patches to protect financial data. Conversely, an e-commerce platform thrives on perfective maintenance. They're always rolling out feature enhancements, tweaking the UI, and optimizing performance to handle peak sales events like Black Friday. The industry totally dictates the maintenance strategy.
Let's move to Section 4 and see how this all builds to the end. The art of closure. Eventually, every piece of software reaches the end of its lifespan, right? Maybe it's being replaced by a newer system, or maybe the underlying business model changed. This brings us to the formal project closure process, where our software hero gets a well-earned rest. It's a sequential process. Step 1 is executing the formal closure, turning off servers and getting that final client sign-off. But Step 2 is arguably the most critical, documenting lessons learned. You have to sit down with your team and honestly assess what went right and what went horribly wrong. Why? Because that feeds directly into Step 3 and Step 4. By being transparent and professional about what you've learned, you transition a one-off project into a long-term client relationship. They trust you. And those lessons learned are the exact tools you use to prepare for future projects, making sure you never make the same mistakes twice. Closure isn't just saying goodbye. It is capturing value.
Section 5. Career Paths and Practices. Before we jump into our review module, let's briefly talk about why you, as a focused learner and future software professional, really need to care about this. Mastering this end-to-end journey opens up very specific, highly lucrative doors for you. The reality of the job market is this. Companies have plenty of coders. What they are desperately searching for are software engineers who understand the complete end-to-end software journey. If you can walk into an interview and intelligently discuss warranty periods, AMC negotiations, and preventative maintenance best practices, you immediately separate yourself from the pack. Grasping the operational side of software, not just the coding side, makes you a highly hireable strategic thinker. It shows you know how software actually lives in the real world. Okay, Section 6, the Student Exam Review module. Let's pick up the pace and synthesize everything we just learned.
Question 1. Which of the 4 maintenance types specifically deals with executing feature enhancements and version upgrades? Got your guess? Since it's driven by making the software better for the user, the answer is perfective maintenance, perfecting the software through enhancements. Great job. Let's hit the next one.
Question 2. What is the primary difference between the warranty period and an annual maintenance contract, or AMC? So the crucial point here is timing and formality. Remember the timeline. The warranty period is the short-term initial support phase immediately following day 1 deployment, usually focused on corrective bug fixes. The AMC is the formalized long-term agreement that covers ongoing support and continuous improvement for years to come. Basically, warranty is the sprint, AMC is the marathon.
Question 3. Let's look at the end of the life cycle. Why is documenting lessons learned an essential component of the project closure process? It is definitely not just busy work. Answering this correctly shows you understand the big picture. We document lessons learned because it directly influences the success of our future projects and builds long-term trust with our clients. It transforms a project's history into a major asset for the future.
Fantastic work on those review questions. Let's do a quick masterclass summary. The biggest takeaway today is that the software hero's journey absolutely does not end at launch. That is literally just the beginning. It evolves through the warranty period, enters long-term support, and requires 4 distinct types of maintenance to survive: corrective to fix it, preventive to secure it, adaptive to keep it compatible, and perfective to make it shine. And finally, it concludes with a strategic project closure that sets you up for your next big success. Now, to make sure you can apply these post-deployment concepts outside of this explainer, here is your practical assignment. I want you to pick a popular application you use every single day. Maybe it's Spotify or Instagram or a banking app. Sit down and map out its post-deployment lifecycle. Give me a concrete, real-world example of what a corrective, preventive, adaptive, and perfective maintenance update would look like for that specific app. Doing this exercise will make studying for your exam an absolute breeze, I promise.
I really hope this explainer has completely changed how you view the life cycle of software. You are no longer just writing code. You are building and maintaining a living, breathing system. As you head out to study, I want to leave you with one final thought to ponder. Think about your own current projects or the software you dream of building one day. When the years have passed and that application reaches the end of its timeline, what lessons learned will your software hero leave behind when it's finally time for your project closure? Keep that in mind, study hard, and I'll see you in